Hi guys, so let's talk about a quant trader interview question. I mean, this is an easy probability question and an ideal candidate should be able to solve it within 2-3 minutes. Anyways, without wasting any time, let's jump into it. So the question is that there are 1,000 people in line to board an airplane that seats all of them. The first passenger in line is drunk and decides to take a random seat. Now, every person who boards the plane after him will either take the seat on their ticket, and if that seat is taken, a random one instead. So what is the probability that last person who is boarding the plane will get to sit in his assigned seat? So usually my first thinking approach in these type of problems is actually to go bottom up. So let's forget about like there were 1,000 people. Let's try to solve it for a general case, like where there were n people and n seats in the airplane. So what is the probability that the last person will get to sit on his assigned seat? So let's denote that probability as Pn. So we have to find Pn. Now let's try to solve in the bottom up way, like where let's say n was 1, so only one passenger was there. So if only one passenger is there, so the last passenger will get to sit on his assigned seat with a probability of 1 only. Okay, because first passenger is the last passenger only and there is only one seat in the airplane. Let's say there were n is equal to 2. Okay, so basically there are two passengers. So what would happen in that case? Let's try to compute P2. So let's say the first passenger, he sits on his assigned seat. Okay, so he can do that with probability 1/2. So in that case, the last passenger will get to sit is guaranteed to sit on his assigned seat. Okay, so hence we multiply 1 because that probability is 1. Let's say he sat on the second person seat. Okay, the first person sat on the second person seat. So in that case, the second person won't be able to sit on his seat because his seat is occupied. So therefore, he won't get his seat. Like in this case, the probability of him getting his seat is 0. So this comes out to be 1/2. So P2 is 1/2. Let's say n was 3. Okay, so let's compute P3. So what would happen in this case, that again we'll repeat the above procedure. Let's say first person sat on his assigned seat, so he can do that with probability 1/3. In that case, everyone will get their assigned seats, so the probability of the last person getting assigned seat in this case is 1. Let's say he sat on second person seat, so now there are two people left, like passenger 2 and passenger 3, and now passenger 2 has to take a random seat. So if you see, this problem is actually now reduced to this sub problem. Okay, like the sub problem is this only, where there were two passengers. So hence in this case, the last person getting his seat is, like, the probability of last person getting his seat is P2. Okay, and let's say passenger 1, like person 1 sat on person 3 seats. Okay, so he can do that again with probability 1/3. And in this case, person 3 won't get his seats, so that's why that probability is 0. If you add this comes out to be, this is 1/3, this part here is 1/3, and this part here is 1/6 because P2 was 1/2. So if you add this will come out to be 1/2 again. Let's take a case where n is equal to 4. Okay, so let's compute P4. Like again, first passenger can sit on his assigned seat with probability 1/4. In this case, everyone will get their assigned seats. So probability of last person getting his assigned seat is 1. Hence we multiply 1. Okay, now let's say first person sat on second person seat. So now there are 3 people left, passenger 2, passenger 3, passenger 4. And now passenger 2 has to choose a random seat. So this problem is again reduced to a case where there were 3 people. Hence we multiply P3 here. Okay, now the other case where first person sat on third person seat. So in this case, person 2 will sit on his assigned seat. Now person 3 and person 4 are left, and person 3 has to choose a random seat. Okay, so this problem is now reduced to this case where there were 2 people. Hence we multiply P2 here. And eventually, let's say the passenger 1 sat on person 4 seat, that is the last passenger seat. So in this case, the last passenger won't get his assigned seat, so that is 0. If you multiply this will come out to be, like, if you add this will come out to be 1/4 plus 1/8 plus 1/8 plus 0, and this is again 1/2. So if I had faced this problem in an MCQ, so I would take on a risk here, like I would mark the answer is 1/2 for our case, because we can see the pattern here, like P2 is 1/2, P3 is 1/2, P4 is also 1/2. But in an interview, you have to actually prove it. So let's try to prove it with the help of principle of mathematical induction. Okay, so let's assume that P2, P3, P4 until Pn minus 1 are all 1/2. Let's try to find now Pn. Okay, so first passenger can choose any seat with probability 1/n. Now let's see what are the scenarios. So let's say he sat on his assigned seat. So in that case, everyone will get their assigned seat. The probability that the last person will get his assigned seat here is 1. Now let's say he sat on passenger 2 seat. Okay, now there are n minus 1 passengers left, that is from person 2 to person n. Now person 2 has to choose any random seat because person 1 has sat on his assigned seat. So in this case, we are reduced to a subproblem where there were n minus 1 people. Hence, the probability here that the last person will get his assigned seat is p n minus 1. Similarly, this will be go on like that. Like if first person sat on third person seat, so now second person will sit on his assigned seat, and now third person cannot sit on his assigned seat, so he has to choose any seat randomly. So there are like n minus 2 people left. And in this case, the probability of last person getting his seat is n minus p of n minus 2. Like this will continue like that, and p2, like this p2 is the case where the first person has actually sat on n minus 1th person seat. So in this case, from passenger number 2 to passenger number n minus 2, they will all sit on their assigned seats. Now passenger number n minus 1 cannot sit on his assigned seat because first passenger has taken his seat, so he has to choose any seat randomly. So there are two people left, that is passenger number n minus 1 and passenger number n, and there are two seats left, and basically we are reduced to this sub problem where there were two people. Hence the answer, like probability of last passenger sitting on his assigned seat is p2. And eventually if first passenger sat on the last passenger seat, so he won't get his seat. So in this case, this probability is 0. So if you see this, like all this pn minus 1, pn minus 2 until p2, we had assumed that these were all 1 by 2. So if we add this, let's see what it comes out to be. So this will actually come out to be something like this. This is 1, and this I think is n minus 2 by 2. From 2 to n minus 1 it is there, so it is n, sorry, this should be n minus 1. Yeah, so if you compute this, this will be 1 by n, and we take, and this will come out to be something like this, 2 plus n minus 1 divided by 2, and I think this should be n minus 2 only. Yeah, so this will come out to be this, and eventually if you see, this will be 1 by n multiplied by this 2 and 2 will cancel out, and we are left with what, n by 2. Now this n in the numerator and denominator will cancel out, and we are left with 1 by 2 again. Okay, let me double check this, that if this is n minus 2 only, because we are adding from p2 to pn minus 1. So they are, yeah, these are n minus 2 people only. So hence this is n minus 2. Okay, so you can see like pn comes out to be 1 by 2 if based on the assumption that all p2, p3, p4 until pn minus 1 were 1 by 2. And we had already computed that p2, p3, p4 are all 1 by 2. So by principle of mathematical induction, we can say that p5, p6 until pn are all 1 by 2. Hence the answer for our original problem is also 1 by 2. So I hope you guys understood this, and please do not forget to like, subscribe and comment on this video. I'll see you all next time.